For this video, we are starting our new unit by talking about ratios. So our learning target today is I can compare values using ratios. Please write down the date that you're watching this and what you already know about the topic. You may not know what a ratio is, but you do know about comparing things, so you can write about that. There were 3 vocabulary words written on your notes sheet, but we're actually only going to write down one of them, and then the other 2 we'll go over on the next video. I accidentally did those twice. So you can just write a ratio is a relationship between 2 or more quantities, and you can go ahead and cross off the other 2. We'll go over those next time. Please pause the video here, write all that down, and restart when you're ready. So a ratio is basically a relationship, and we're going to start by talking about what it is and how we write it. And there's 3 ways we can write it. So let's say we had a room, and in this room we have 3 boys and 2 girls. If I asked you to write the ratio of girls to boys, the first way to write that is with a colon. Now I have 2 girls and 3 boys, so my ratio would be 2, and then the two dots that make a colon, and a 3, because there are 2 girls and 3 boys. My second way to write this would be with words. I would say there are 2 girls, 2, 3 boys. And then my last way is as a fraction. I would write it's 2 over 3. This is really, really important. This is a question that will show up on a test, on a quiz, anything like that. When you're asked what are the 3 ways to write a ratio, the 3 ways are with a colon, with words, and with a fraction. Now, this is the ratio of girls to boys. If I wanted to write the ratio of boys to girls, that is a different thing because order matters. Boys to girls is not the same as girls to boys. In girls to boys, you put the number 2 first because the word girls is first. Then the word boys comes second, so the number for boys came second. Now, if we switch to do boys to girls, we have to put the number of boys first. So with a colon, we would have 3 colon 2 because there's 3 boys and 2 girls. In words, it would be 3 to 2. And as a fraction, it would be 3 over 2. Again, it's really important. 3 over 2 is not the same as 2 over 3. Girls to boys and boys to girls is different. And the reason that we put them in order is so that if someone coming along were just to say, oh, the ratio of boys to girls is 3 to 2, they need to know that the order that it comes in is the order that's in the problem. Now, another question we could be asked is what is the ratio of boys to total? Well, if we were asked that, we would say, okay, there's 3 boys, and then the total number of students, well, if we count, there's 3 boys and 2 girls, so there's 5 total students. So my ratio of boys to total would be 3 to 5, or 3 colon 5, or 3 over 5. Now, these are different things. When we compare girls to boys, this is called a part ratio. We're comparing the part of the group that is girls to the part of the group that is boys. When we compare boys to total, that is called a part to whole ratio. We're comparing the part of the group that is boys to the entire group. These are 2 very different things if we're comparing 2 parts or if we're comparing one part to the whole thing. So the rest of our problems here with ratios, it's usually going to be words. This is why it's really important to keep the order. So if I was to ask, if we had a ski resort that has 12 easy, 24 intermediate, 6 difficult, and 10 expert trails. What is the ratio of easy to expert? Looking at this problem, I see that I have 12 easy and I have 10 expert. Okay? So I could write that as 12 to 10, or as 12 colon 10, or as 12 over 10. Now, once I write it as 12 over 10, I immediately see that this looks like an improper fraction. And one thing that's really important about ratios is that they can be simplified. And in fact, we usually want them to be simplified. So now that we see that 12 over 10 can be simplified, I'll say, okay, let's simplify this. If I divide both top and bottom by 2, I would end up with 6 over 5. That means I could also write it as 6 colon 5 as 6 to 5. These are the same ratio. 12 to 10 and 6 to 5, they're the same ratio. Just like 12 tenths is the same as 6 fifths. So when we're doing this, we are going to want to always simplify our ratios. Now, if I were to ask you if this was a part to part or a part to whole ratio, well, looking at this, I see I'm comparing the part that's easy to the part that is expert. So this is a part to part ratio. Okay, let's try the ratio of difficult to easy. Well, there's 6 difficult, and there's 12 easy. That means my ratio is 6 to 12, 6 colon 12, or 6 over 12. Again, I see that this can be simplified. I can divide both top and bottom by 6, leaving me with 1/2 and 1 to 2. This is, again, a part to part ratio. So on your own, see if you can do the final part, which is the ratio of intermediate to total, and come back and restart the video when you're done. So when I go to do this, I say, all right, there are 20 intermediate trails. If I want to add up the total, 24 plus 6 is 30, 30 plus 10 is 40, 40 plus 12 is 52. So I have 24 to 52, and I can write that in my other ways. I see right away that this can be simplified. So if I simplify this, if I divide by 2, I get 12 over 26. And if I divide by 2 again, I get 6 over 13. So I can rewrite these as well. Now this one, this is a part to whole ratio. I'm comparing the parts that are intermediate to the entire group. The next type of problem you might get is being asked if two ratios are equivalent. So if you're asked, are these ratios equivalent? Let's say it was 5/8 and 25 over 40. The easiest way to compare these and see if they're equivalent or the same is just to simplify them. So here I would say, okay, 5/8, that can't be simplified, but 25 over 40 can. So I divide by 5, and I get 5/8. That means yes, these are equivalent. Now, we might not always be asked this in a way where it's fractions. So let's say I was asked to compare 6 to 12 and 18 to 45. Now, one way that sometimes I like to do this is say, okay, if I'm going to be asked to do this, I like to actually write them as fractions because then they're a lot easier for me to simplify. Here I see that 6 over 12, I can divide by 6 on top and bottom and get 1 over 2. So I want to see if I can simplify 18 over 45 to also get 1 over 2. Well, I see that 9 goes into both the top and the bottom. 18 divided by 9 is 2. 45 divided by 9 is 5. I can't simplify these anymore. So I have 1 over 2 and 2 over 5. These are not the same. So my answer here would be no. They are not equivalent. The last type of problem I might be asked is what value will make these ratios equivalent? Remember, equivalent just means the same. So in this case, I would say, okay, let's say this problem was 4 over 9, and I'm told that that equals 12 over something. Now, you should have seen problems like this before, and it's actually the same as if they were equivalent fractions instead of equivalent ratios. But I can treat them just like equivalent fractions. Here I can say, okay, I want to know 4, how do I get from 4 to 12? Well, this would be 4 times 3. So that means I need to do times 3 on the bottom here as well. 9 times 3 is 27. So my unknown value is 27. This also still works even if I'm not given them as fractions. Let's say I was told that 5 7 is the same as something to 49. Again, I like to write these as fractions because then we're able to use what we know about equivalent fractions to help us solve this. For this one, I see that 7 times 7 is 49. So I have to do the same thing on the top as well. 5 times 7, so that my unknown will be 5. Please feel free to rewatch any sections of this video that you need. Let me know if you have any questions, and have a great day.